There it goes. All right. And so now our bases are the same. So since our bases are the same, what can I do now? I'm going to take my exponents and rewrite them as just an equation by themselves. Okay? So can I solve that? How do I solve that?
Subtract 1, subtract 1.
So x equals?
3.
Perfect. That's our answer. All right. Then we're going to look at number 14. So is there a way I can make 27 equal 9? I had to do dividing, so I can't do it by raising a power, right? Can I make 9 27? How? By multiplying by 3, but would that be by raising any powers? Is there a power that I can, is there a base I can make both of them? So that I could raise it to a power and get those numbers? 3. Because 3 to the what power gives us 27? 3 to the third power. So we'll do 3 to the third times x minus 4 is equal to, how do I get 9?
3 to the second.
Then we'll do times x minus 3. Now our bases are the same, so I just need our exponents. So 3 times x minus 4 is equal to 2 times x minus 3. So do me a favor and solve that for me for x. I can do that.
ACT math.
Oh, yes, it was you.
It was me.
Just throw gum at that.
Rude.
That was nice.
To throw. What did we say about throwing trash yesterday? I had a whole thing.
I don't know.
I feel very upset when you throw trash because it messes up my room.
Next time.
Next time, can we try not to do that?
There you go.
Thank you so much.
Yes, correct.
I really do.
I
glitched. I glitched with Dalton.
glitched. 9 inches. 9 inches.
Alright, so basically I distributed and now I'm stuck.
Now you just.
No, I'm not.
Wait, those equations are so much easier than.
What is the answer? What is x equal?
6.
It is 6. All right. Now, 15. Okay. There is a what? Can I make 2 into a half? How? What power can I raise it to? -1. So I can take this and do 2 to the 3x minus 2 is equal to 2 to the -1 times -4x. All right. So we get 3x minus 2 is equal to, what does a negative and a negative make? And can y'all solve that for me for x?
You mean maybe.
I mean, you can. You definitely can.
It's
-2. Look at us go.
good job.
All right, now let's do. Sorry. Yes, ma'am. Yep. Because it makes the 2 go down to the denominator, which will make it 1/2. 2 to the -1. Yep. All right. Now, do 16 for me all on your own, please.
Take mine while you're good.
Yeah, we are going to do those together.
Hey guys, you know that 2 to the 25th is
Because you can.
335,544,032.
Now I do.
I think that's actually, I think you,
335,544,032. 44,032.
I don't think that's right.
It's right here.
Have you seen Wicked yet?
No. I know. Me and my husband were gonna watch it, but we only had we didn't have enough time.
You gotta read it.
Yes. Kipton. Yes. Okay. What should I write next? What should I write next to do this problem? Yep. So I get 3x plus 4 equals 3 what? To the second.
Wait, why would we do 3 to the second?
Because 3 times 3 equals 9.
That's what
What?
Because we have to rewrite 9 with a base of 3. All right. Then we do x plus 4 equals 2. So x equals
negative 2.
-2.
See, I understand it.
I've never done that. I was just worried I was like, and then I'll have to go ball to restart.
Wait, so.
No, like highlights, I think it looks so good.
You could do baby lights first, and it would be really light.
Do that. Threes.
All right, number 19. I didn't dye my hair until after I graduated high school.
Well, I was applying my own hair to do my own hair, so I turned it orange. Yeah. Oh, can I go to the
Yes, ma'am.
All right, say it.
All right, now this one. Okay, this one has 2 exponents on one side. Okay, but I am multiplying them together. So what do I need to do with those exponents? Add. So that is the same thing as saying x divided by 2 plus x divided by 3 is equal to 3 to the 9th. Now, do I need to do anything to my bases? Or are they good to go?
They're good.
They're good. So we can do x over 2 plus x over 3 is equal to 9. Can I add those as they are now?
No.
What do it have to have in order to add 2 fractions? Same denominator. What is the least common denominator? 6. Okay, so what do I need to multiply the first fraction by to get that? Not just 3, but 3 over. And what do I need to multiply the second one by? And then we get 3x over 6 plus 2x over 6 equals 9. What is 3x plus 2x?
5x.
5x divided by 6 equals 9.
Wait, how? And then you put 1 under the
Now what?
1 under the 9.
Not number 1. So you get 5x over 6 equals 9 over 1.
I can do that.
And then you would.
Then I could multiply by the reciprocal. Okay, we can do this one of 2 ways. Okay, we can either put 9 over 1 and then multiply both sides by the reciprocal of 5/6. Okay, or you can do it in 2 steps where you multiply both sides by 6, get 5x equals, what is 9 times 6?
54.
Then divide it by 5, and x is equal to 54 fifths.
Oh my gosh.
Yes, ma'am.
If you multiply 5x.
Be happy.
Do what?
Are we done?
Why did I do what with the 9? Because this side right here equals 9. Shh, y'all be quiet, please. I'm trying to answer a question. So this side, we have this and this. Okay, we have to add those together, and it equals 3 to the 9th. So we have to take these exponents and equal them to those exponents. And that's where we get the 9 from. Yes, Ramsey?
So, well, how do we get 5 over 5? What is it? 6's cancel out, so it's 6 times 5, which is.
And then I divided both sides by 5.
Oh.
And so those cancel, and I get just x equals 54. Yeah. All right.
That was a lot.
I'm not.
Might miss a step.
All right, once we are done with that, we are going to go ahead and we are going to go to the next page.
Well, I didn't get back to mushroom. Can I please get 2?
Yes, ma'am.
Wait, what?
So 6.3.
Wait, but then I want to call it. Can I call it? I want to call it. I'm not right now.
All right, me.
And I took medicine. Right, but it's not helping. You gotta go up.
All right, we're gonna go to 6.3.
Okay.
Shoot, no,
Yo,
you
what?
said that you looked at Matthew.
Why?
Move him away from the truck.
I'm actually gonna fail this test.
I did. But it was mostly because I needed to get Charlie away from Maddox. And then I had to move, and then I accidentally had Jaden next to him too, and so I had to move Jaden today.
Yeah, he was very sad.
Yeah.
So do you want to listen to Hamilton?
I love Hamilton.
Is that it?
I'm just.
You don't listen to like Mean Girls or like Hey.
I've listened to Mean Girls before.
Wait, actually?
I've listened to some of it. It just, I have to be in a mood. On Wednesdays, we wear pink. For Christmas, for my mother.
We'll ask your mother where you got it and then you let me know. That's really cute.
Thank you, thank you.
Also, I'll say my mom and wait on Wednesday.
That's fun.
Wait. So my new favorite show tune is Dear Evan Hansen.
I do like Dear Evan Hansen.
It's so good.
All right, anyways. Now, Anthony, you're being a disruption.
Oh.
What are you doing?
Hey, who's doing it?
All right. So we're going to look at 6.3. Okay. So an exponential function function
You see how the word's right above it? I'm just drawing here. Okay, Miss Stevens.
An exponential function is a function written in the form of y is equal to a times b to the power of x.
What'd you say?
What'd you do?
Addie is having a day.
How are you supposed to get
Oh,
it
my
open?
zipper open.
I can't get it on lunch break.
How are you supposed to get it open?
I'm so sorry, Addie.
I actually hate this subject right now.
Set it down on the floor, and we're going to come back to it in a second. Okay, it's going to be okay. So, where a and b are constants, a cannot equal 0, b has to be positive, and b cannot equal 1. Okay? Shh. Y'all, please stop talking. Okay, so a is the initial value. Okay, and when I mean of initial value, we are actually talking about the y-intercept. Because we're talking about whatever the output is when we input 0. Okay, and then b is our constant ratio. So it's whatever we need to multiply the previous one by to get the next one. Okay. So I want us to look at this table right here. So in this table, we have our input. And we have our output. So what we're going to do is we're going to start by finding our initial value. Or whatever our A is. So in this problem, what is our y-intercept? When I plug in 0, what do I get out? 4. So A is 4.
Plug in 0, I get 4.
Now, for our constant ratio. All right, for our constant ratio. B. All right, what do I need to multiply 4 by to get 12?
3.
What do I need to multiply 12 by to get 36? 36 by to get 108? And what do you think our constant ratio is going to be? 3. Okay. You can also find this by taking whatever your value is at 1 and saying the 12 divided by 4. And that would tell you that it's 3. All right, now we're going to write the equation for that. So for our function, okay, for our function, what is my A?
Your A, 4.
So we're going to do 4 times 3 to the power of x. And that is our exponential function. The exponential function just means we're going to have an exponent, and that's where our x is going to be.
So how are we going to find out our exponent?
You would have, sweetie, we just did a problem where we solved for the exponent. But right now we have a function, so we're looking at the whole function. We're not necessarily trying to solve it for x, because we know what x is, and it depends on this right here.
Okay.
If it was a problem you needed to solve, you would do it just like we had done those problems
So
just before
if
that.
X was 1, we put just a 1. If X was 2.
If x is 1, you would plug in a 1 and you would get out 12. If x was 2, you would plug in a 2 and then you would get 36. And so on. All right. Now, is this right here going up or going down?
It's going up.
Our values are going up, right? And so since is that increasing or decreasing if our values are going up? Increasing. Since it is increasing, we consider that to be a growth function. So an example of a growth function is like how your interest accrues in the bank. Like if you start out with a really small amount of money, are you going to accrue that much interest that fast?
You keep on
No.
paying.
But if you start with a lot of money, how fast are you going to accrue that interest?
Real quick.
Real quick. Like you make more interest on $1 million than you do 100. And that's also one thing that's very unfair about being a millionaire, because you just put $1 million in the bank, then you can live off that interest for the rest of your life and just keep the million. It's very unfair.
Well, they work for the
You
million.
gotta say they got the million somehow. They gotta work for it.
Well, some of them do, but then some of them get it as like passed down to them, like generational wealth. I wish my parents had millions of dollars. Yes.
Miss Dalton,
Yes, ma'am.
Riley Eldy has a dismissal.
Yes, ma'am. Yes. Yes, go ahead. All right. Now for this next one. Shh. Okay, for the next one. When x is 0, what's our y value?
When X is 0, our Y value is
1, 0.
Where does this graph cross the y-axis? 120. When x is 0, y is 120. When x is 1, what is our y value?
X is 1, our Y value is
60. When x is 2, what is our y value?
30.
When x is 3, our y value is?
15.
All right, and it keeps going.
That's
So in this case, what is our initial value?
121.
120. Because that is where our y-intercept is. That is where our x is 0. All right, now we're going to look for our constant ratio. This is our B. To go from 120 to 60, what would I need to multiply by?
2.
Not 2.
Divide by 2.
Divide by 2, which is the same as multiplying by a half. Yeah. So our constant ratio is 1/2. Because what's half of 120? 60. What's half of 60?
30.
And so on. All right. Now we can write the function. What is the first thing I would need to write?
You're 120.
So I would do 120 times. Then I would do 1/2. What power does that 1/2 need to go to? The x power.
Do they always go to the x?
That's what makes it exponential. Yep. Because the exponent. That's what makes it, yep. Now, is that one increasing or decreasing?
Decreasing.
Decreasing. Okay, and since this is decreasing, that is an example of a decay function.
Oh, so we're in chemistry.
Like the half-life of a radioactive isotope.
You didn't try to spread my hair without it.
No, that has an exponential function. Your height is kind of like an exponential function than like a decay function. Because do you grow faster when you're a baby or when you're like 15?
When you're a baby.
A baby, right? You're growing so much when you're really young, right? You keep growing, you grow really, really fast. What happens as you get older?
You start to not
You
really.
start to slow down,
Yeah.
You start
right?
shrinking.
You don't start shrinking yet. We're not there yet. But you grow more in a year at 2 than you do in a year at 15. And then eventually what happens when you hit like 30? Are you growing anymore? No. Okay? So it starts off you're growing really, really fast, but then your growth rate slows down. Okay? And so stuff like that can be modeled by exponential functions. All right. We are going to stop with the lesson there, and we're going to finish up our 6.2 homework. It's only 4 more questions.
I got 12.
We are going to go to the homework. You should have 1 through 12 already done from yesterday. And now you're going to go in and you're going to add in 13, 14, 15, and 16. There's not 17 through 20. But feel free to make them up.